Average velocity of 6 meters per second tells us that after 50 seconds, the car is now 6 times 50 equals 300 meters to the right of the starting point.
Very often, the velocity of an object in motion changes in time. The rate at which velocity changes is described by another physical quantity called acceleration.
In everyday conversation, to accelerate means to speed up. In physics, the meaning of the word acceleration is more general. Any object whose velocity is changing is said to be accelerating. The average acceleration is defined as the change in velocity divided by the time interval over which that change occurs. Using the notation introduced earlier, the acceleration is delta v over delta t. Again, remember that the arrows above the quantities indicate their vector nature. The instantaneous acceleration is defined in a similar way, the change in velocity of the time interval where the time interval approaches 0. So acceleration is a vector and it is measured in meters per second, or meters per second squared, or meters second to minus 2. Now, 2 quick points about acceleration. Velocity, as a vector quantity, is defined by its magnitude or size and its direction. A change in a vector quantity means a change in its magnitude or a change of its direction or a combination of the two. Therefore, change in velocity means speeding up or slowing down, changing direction, or a combination of both. Therefore, for example, an object undergoing circular motion at steady speed is accelerating since the direction of its velocity changes all the time. One last point about acceleration. I noticed that quite a few students are under the impression that negative acceleration automatically means slowing down, or deceleration, to use a colloquial term for a decrease in speed. This is not exactly true. The direction of the acceleration depends on what we consider to be the positive direction for velocities. And it just happens that in most cases when an object slows down, we take the direction of motion as our positive direction. Let's have a look at this quick example. The speed of the car at A is 18 meters per second and at B is 4 meters per second. Just to keep it simple, let's say that it takes 10 seconds for the car to move between A and B. If we choose the positive direction to the right, so it coincides with the direction of motion, the acceleration is final velocity minus initial velocity divided by time. In our case, the change in velocity is plus 4 minus plus 18 equals minus 14 meters per second. Divided by 10 seconds, this gives us an acceleration of minus 1.4 meters per second squared. I use the plus signs to emphasize the direction of the velocities. The negative sign of the acceleration tells us that the direction of the acceleration is to the left. Now, if we take the positive direction to be to the left, the change in velocity is minus 4 minus minus 18 equals 14 meters per second, and this divided by 10 seconds gives us an acceleration of 1.4 meters per second squared. The positive value tells us again that the acceleration is to the left. Whichever method we used, they both gave us an acceleration of 1.4 meters per second squared to the left. You can see now that the negative sign in the first method does not have any special meaning. A good rule of thumb that can be used to identify a motion in which the moving object slows down is that the change in velocity has an opposite direction to the direction of motion.
Let's now summarize the topics covered today.
The average speed is the distance over the time interval. The average velocity is displacement over time interval. The instantaneous velocity, or simply velocity, is the displacement over time interval where the time interval is very, very small. The instantaneous speed, or simply speed, is the magnitude of instantaneous velocity. Average acceleration is defined as change in velocity over the time interval. Instantaneous acceleration, or simply acceleration, is a change in velocity over the time interval where the time interval is very, very small. Change in velocity means a change in speed and/or a change in direction. Speed is a scalar. Velocity and acceleration are vectors. Speed and velocity are measured in meters per second. Acceleration is measured in meters per second squared.
We've reached the end of this third podcast. If you have any questions or comments, please contact me at ibphysicshelp@gmail.com. You can also post your comments on my webpage at www.ibphysicshelp.net or my YouTube channel. Simply search for IB Physics Help. See you next time.